Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 2, Section 2, Evaluating Algebraic Expressions. So in order to do this, two steps are involved. Step 1, this is the word substitute, and you actually have to substitute just like in a sporting event when a coach substitutes one player in for another. You're going to take out the variable from the expression. We're going to take out the letter x or whatever the letter is, and we're going to put in the number. After you take out the letter and put in the number, then you do the math, and you find the answer by following PEMDAS, just like we always do. So we'll look at some examples of that in just a moment. This term, formula, I believe you already know. It's an equation that shows the relationship between some values. I hope you've seen many formulas. One that we did in pre-algebra was a squared plus b squared equals c squared. And the relationship that this formula shows are the sides of a right triangle. When you square the two legs and add them, it's equal to the hypotenuse squared. There's many formulas in science and math, and so we need to get used to working with these. All right, the next thing we're going to look at is some symbolism. Now, some of these you've already seen before. Equal, not equal. This one, this wavy line, equal sign, it means approximately equal to. I use that a lot in class when we're doing a problem and I round off. I'll always put a wavy line that it's approximately equal to that value that I just rounded off. So please look through this list, and if there's any symbols that you're not familiar with, please write them down so you decide what you need in your notes. Right, this next table here are just some familiar formulas, and they will ask you to use some of these in your assignment. So again, if you need to write down any of these area formulas for these shapes, please do so. An easy way to remember perimeter, if you don't want to write all this down, is to find perimeter, you simply add all the sides of whatever the shape is you're working with. We do not call a circle, we don't use the word perimeter with circle, we use circumference. The word circumference just means the distance around the outside of the circle. So you might want to write down these circle ones because those might not be so familiar, and we do use them in our assignment. So when you're using formulas, when you're asked to do a problem involving any formula, please write it down. Search out the formula you need, write it down because it guides you where you plug in the numbers and what operations you do. The next step, whether you're in math or science class, you substitute in the correct numbers where they belong in the correct place in the formula, and then you evaluate whatever the one that you're supposed to find, the answer. All right, now let's look at a few examples. In this first part, we're asked to evaluate xy plus z when x equals -2, y is -3, and z is 12. So we substitute those into the correct location in this formula. So we put -2 where the x is, we put -5 where the y is, and then put in your plus sign, and then put 12 where the z is. And then this is what I call the do the math stage. -2 times -5 is 10. And 10 plus 12 is 22. In example 2 here, we have some exponents. So let's again plug in the numbers in the right place. -2 squared times -5 is the y, and then we have a subtract sign, minus 12 squared. So according to PEMDAS, we need to do these exponents first. So -2 times -2 is positive 4. Watch your signs there. And we will be multiplying that by -5. And then we're subtracting 12 squared, which is 144. Now, did you notice how in this one, we're squaring the whole x, so we have to square the entire -2. Here, we're just squaring the z. This subtract sign is not part of being squared. So please notice here when you're squaring the negative sign, you get a positive answer. When you're just squaring the 12 and you keep the subtract. So we got to watch our PEMDAS. So then the answer, and there's the bell, we would have negative 20 minus 144, and that would be a negative 164. And now we get to do an example with some fractions. So I'm going to plug in the fractions to the right location for example 3. All right, if you need to, remember you can always put a whole number over 1. So this is like 2 over 1 times 1/4, which gives us 2/4, and I could reduce that, and maybe I will. Plus, again, put the 3 over 1 if that's helpful, plus 3/2. Now I notice that to get common denominators here, all I need to do is reduce 2/4 into 1/2, and then I can add 3/2 to that. That would give me 4/2, which reduces down to 2. All right, in example 4, I have substituted in the fractions for the a, b, and c. I need to do what is in parentheses first. So I'm going to change these to common denominators. So I have 2/4 plus 3/4. Then we go ahead and add them. We would get 5/4. And then the last step is to multiply. Remember, we multiply fractions straight across. So my final answer is 5/16. Now let's put in the fractions where they belong in problem 5. Okay, doing that multiplying first. 5 times 1/4 is 5/4. And then in my numerator here, I'm subtracting a 3/4. So let's go ahead and combine what we have in our numerator. We would get 2/4, which is the same. I'm going to go ahead and reduce that to 1/2. Now this may look very scary and freaky, but it's not. It's just division. So you can rewrite this if that would be more friendly looking if you write 1/2 divided by 2. This is what's called a compound fraction here, and you don't need to wig out. It's fine, but for some reason this scares students. So if you don't like it written this way, go ahead and write it this way, and then it becomes just like any other fraction problem that we're asked to divide. We don't divide it. Remember, we don't divide fractions. We leave the first fraction the same, so we leave the 1/2 the same. The divide sign goes to a times sign, and then you take the reciprocal of the second. Well, this is 2 over 1, so when you take the reciprocal, it's 1/2, and so the answer is just 1/4. In our last example here, we are asked to find the area of a circle that has a radius of 9. So like I said, please do write down the correct formula. If you don't know the formula for the area of a circle, look it up, because you can't even proceed without it. The area of a circle is pi r squared. The only number we need to plug in here is the radius, which is 9. You have a calculator key that is the value of pi, and I would like you to use that key because then it's extended to many decimal points, and that will give you the most accuracy. If you use 22/7 or 3.14, you're reducing your accuracy because you're rounding off before the answer. So pick up your calculator. You know that 9 squared is 81. So type in 81 times, and then find the pi button on the 84s. It's a blue function right above the key above the division sign. So anyway, take 81 times, use the pi button in your calculator, and then you'll get a long answer. You'll get 254.4690049, and that does keep on going forever. But now we can just use our approximately equal to sign. We're acknowledging that we are rounding off. And perhaps I could have put in the directions here to round to the nearest hundredth. So here's the tenth, here's the hundredth. So rounding off correctly would be 254.47. Now let's talk about units. We are in feet. So area is not measured in linear feet, area is in square units. So the correct units would be feet squared. All right, now you have the knowledge you need to do section 2.2, so have fun with that.